Now, let's take a look at the well water we're using for irrigation. This water analysis was done by Monterey Bay Analytical Services Laboratories a year before the soil analysis. But once again, we can see that many things are out of balance. Let's start with the anion-cation balance. We have a value of -4, which is actually okay. The cation-anion balance refers to the positive and negative charge elements in the water and how they balance each other out. In this case, the positive and negative charges seem to be relatively balanced, which is a good sign. Next, we move on to the total dissolved solids or specific electrical conductance. That one doesn't really matter too much in this case because it mainly tells us how many dissolved minerals are dissolved in the water and their electrical conductance. It is supposed to be around 0.55, and here we have 0.59. So that's acceptable and not really a concern. Then we move on to boron. We have 1.2 parts per million or milligrams per liter, when the maximum should normally be between 0 and 0.5 parts per million. So we have way too much boron. Now let's look at the calcium in the water. Calcium is actually beneficial, and here we have a level of 49 parts per million, which falls within the ideal range of 20 to 60 parts per million. So that is good. Next is copper. Copper was not detected in the water, but ideally, well water should contain around 0.2 to 1 parts per million because plants do need copper in small amounts. Then we move on to water hardness. Water hardness refers to how much mineral scale or scale buildup the water can create over time. It tells you the amount of minerals that are present in the water. In this case, we have a value of 212 parts per million, when ideally it should be between 0 and 200 parts per million maximum. Excessive hardness can stunt plant development by causing nutrient lockout, elevating the soil pH to undesirable alkaline level, and leaving crusty mineral buildup that stresses the root system. Under the right conditions, many of these minerals can actually become nutrients and food for the plants, as long as everything stays in balance. Now, moving on to iron. In the water, we have 608 parts per million, which is pretty high. If we look back at the soil samples, we can see there is already a lot of iron in the soil. Ideally, a good balance will be around 100 to 200 parts per million maximum. So 608 parts per million is definitely excessive. Next is magnesium. We also have dissolved magnesium in the water. In this case, we have 21.6 parts per million, while the ideal range should be between 10 and 30 parts per million. So this level is not excessively high. Now, moving on to manganese. In the water, we have 57 parts per million of manganese, which is considered high. Ideally, it should be between 0 and 40 parts per million maximum. Next is potassium. Potassium should normally be between 10 and 20 parts per million. And in this case, we have 18.2 parts per million, which is good. Potassium dissolved in water can be beneficial because potassium is an important plant nutrient. Now let's look at silica. Silica is one of those micronutrients that can benefit plants. And because of the soil conditions in this well water, we have a level of 65 parts per million, when ideally it should be between 20 and 50 parts per million maximum. Next is sodium. In the water, sodium is at 248 parts per million, when it should be no higher than 50 parts per million. And remember, in excess, sodium is toxic to plants, sodium is toxic to humans, and in high amounts, sodium is harmful to most living things. Next is zinc. Zinc was not detected. And again, zinc is one of those essential micronutrients that plants need in small quantities. Ideally, it should be between 0 and 2 parts per million. Now we move on to arsenic. We are not too concerned about arsenic on this case because it is at 4.9 parts per million and the acceptable range is 0 to 10 parts per million. So arsenic is within balance. Then we have cadmium. Cadmium is at 0.4 parts per million, which still considered acceptable because the maximum is 0.5 parts per million. So it's still within a manageable range. Next is chromium. We have a level of 2.2 parts per million, which is okay since the acceptable range is between 0 and 30 parts per million. So chromium is fine in the water. Lead was not detected, which is good because we definitely don't want any lead in the water. We move on to chloride. Chloride or chlorine in small amounts is actually essential for plants. In this case, we have 168 parts per million. Since this is well water, this is not like domestic city water where the water company adds large amounts of chlorine and other chemicals to the water. Chloride is a natural occurring element found in many places, and here we have 168 parts per million, which is a little high because ideally it should be between 70 and 140 parts per million maximum. Chlorine is part of chlorophyll, so plants use it in the process of making chlorophyll. Next is fluoride. We have 0.1 parts per million, which is fine because the acceptable range is between 0 and 0.5 parts per million maximum. Then we move on to nitrates. None was detected. Nitrates are usually remnants of fertilizers, and because this is well water and there are now fertilizers leaching into the groundwater, none were detected. The same goes for nitrite, none detected. Orthophosphate was also not detected, even though it ranged between 0 and 10 parts per million is considered tolerable. Having none detected is perfectly okay. Next is sulfate. In the water, we have 122 parts per million, which is within a good range since anything between 0 and 150 parts per million is considered acceptable. Then we move on to total alkalinity, which is basically the calcium carbonate dissolved in the water. In this case, it's pretty high. We have 470 parts per million, when ideally it would be better to have between 50 and 150 parts per million. Next is bicarbonate dissolved in the water, and this one is also high. We have 573 parts per million, when a good range will normally be between 90 and 150 parts per million maximum. High bicarbonate levels lack the uptake of iron, zinc, manganese, and phosphorus to the plants. That is part why plants are deficient in these elements. After that, we have several other tests used for quality control, and overall, those results are actually pretty good. The pH of the water tested in the laboratory was at 7.9, and that's mainly because the water contains large amounts of dissolved calcium carbonate. Finally, sulfide was not detected in the analysis. However, because of the presence of iron sulfide and sulfur-reducing bacteria, when the water stays inside the hose for several days, it comes out with a strong rotten egg smell. That's exactly why understanding water chemistry is so important.